to Sacred Spiral ASMR. Good morning, class. You might be joining me at a different time of day, so good afternoon, good evening, and good night. Today's date is September 21st. Does anyone know the significance of today's date? That's right, it's the first day of autumn. It's the fall equinox today. And for our lesson, I would like to show you on the whiteboard some scientific information that is common knowledge that you can look up for yourself about the movement of the planet and how these different relationships of placement and movement help to create our seasons and the times of day. I've been a homeschool parent for about 10 years, so I have a lot of office supplies. We have a lot of colors to choose from today. We have a lot of colors. We're going to start with the earth. Please keep in mind this is a science lesson, not an art lesson. There's our earth. We have the North Pole and the South Pole. The first thing I want to tell you about is the Earth's axis. Its axis is an imaginary line that runs north to south through the Earth, and the Earth rotates in an eastward direction around this axis. The axis does not run directly north and south. It's actually on a tilt of about 23.5 degrees. Let me rewrite that for you. It's a little messy. 23.5 degrees. That's a little better, isn't it? Now, it's this tilt of the Earth on the axis that creates our seasons. Let me show you that. Over here, we have the sun. We have our earth. As the earth orbits around the sun, because the earth not only turns on its own axis, rotates on its own axis, it also orbits around the sun. As it does that orbit around the sun, the tilt changes relative to the position of the sun, so that when the earth is tilted with the north pole, the north hemisphere towards the sun, that is when the north experiences the summer and the south experiences the winter. Let's get some more colors in here. As the position, the relative position and the sun and the earth changes with the orbit, and now the southern hemisphere experiences summer. and the north experiences winter. So again, to review that, it is the Earth's tilt on its axis as it orbits around the sun that creates the seasons, which are opposite in the northern and the southern hemispheres. Going back to the Earth and its tilt. If we imagine a second imaginary line running across the widest part of the Earth, this line running around the diameter of Earth is called the equator. The widest part around the center of the Earth. Again, that would be called the diameter. If we were talking about a spherical object other than Earth. Speaking of Earth specifically, it's called the equator. As the Earth is rotating, it moves faster at the equator than it does at the poles. The Earth makes a full rotation on its axis, rather in this direction, the eastward direction. The Earth makes a full rotation on its axis in 24 hours. It's a full rotation every 24 hours. And this is what creates day and night. So when the portion of the Earth that you live on is facing the sun during those hours, you have sunlight. As it turns, you have night. Day and night is caused by the rotation of the Earth. Backing up for a moment, I would like to talk to you about the force that keeps all of the planets in the sun's orbit. That force being gravity. Gravity is the force that pulls two objects together. A force which pulls two objects together. Apologize, my writing is a little messier than I would like, given my angle here. Calculus was actually invented in order to calculate the elliptical orbits of the planets. It was once thought that the orbits were circular. Now, the reason why our orbits are elliptical is a little bit complicated. I'm not sure I can explain it thoroughly myself. But I would like to show you the equation for figuring out gravity, because it really does help to paint a picture of some of the laws of gravity. So we have two objects. We will call these planets. And we are wanting to find out the force between them, pulling them together. In order to figure that out, you must find the center of these planets and calculate the distance, which here is notated by the letter R, the distance between the centers of the two planets. So this equation, to find the force, you have universal gravitation, which is, to figure out universal gravitation, there's another term for it that I'm not remembering right now. There's a very complicated equation, relatively complicated equation for figuring out universal gravitation. But again, this is just to show you some of those basic laws of gravity. So in order to find the force between these two planets, we would have to calculate the universal gravitation by the mass of the first object by the mass of the second object over the distance squared. My very basic and simple understanding of this is that the greater the mass, meaning the more matter these planets contain, the greater the mass of any object, the greater the force of gravity it will have. So increase mass is an increase gravitation. Is an increased gravitational force. The other important piece of this is that the less distance, the greater the gravitational force. So when planets or objects are close together and both very large, that's when they're going to have the greatest force of gravity between them. So we can now remove my messy equation and keeping these realize you can't see my force down here. Keeping these laws in mind and going back to thinking about elliptical orbits. We see how when we have the sun as the orbital focal point, the largest object in the solar system. That's why it's called the solar system, solar meaning of the sun. The sun being the highest mass object in our solar system is the center, everything else revolving around it. However, because of these facts, the orbits are not circular. The orbits are elliptical. So when a planet is at a closer point to the sun, it will be moving faster than when it is at a farther point in the ellipse away from the sun. It will be slower here, faster as it becomes closer to the sun, moving in this manner. Now, while the ancient Egyptians and other ancient cultures had a lot of really advanced awareness of some of these things, they weren't documented in a way that is readily available and easy to interpret today until you move further into the future. So if you're interested in the modern-ish origins of studying the elliptical orbits, you're going to want to start with someone named Kepler. If memory serves, Sir Isaac Newton based a lot of his studies on Kepler's work. Since I mentioned distance's effect on gravity, I think it makes sense to talk about the Earth and its moon briefly. Again, not art class, and definitely not accurate ratio here. So this will be our moon. And this will be our Earth. And we have the sun over here. But in reality, this distance is much greater than this distance. So given this information, do you think the sun or the moon would have more effect on the Earth's tides? The ocean tides. The moon has a greater effect on the Earth's ocean tides given the closer distance. So the rising of the tides, high tide, is the moon's gravity pulling the surface of the water up. And when the moon has less effect on, and when the moon is further away from a particular body of water, again based on our rotations, because this moon is orbiting us as well as we are going around the sun, the moon is going around us. So there will be greater distance between the moon and certain bodies of water at different times. So we have high tide and low tide. There are typically 2 high tides and 2 low tides in a 24-hour period. Now the sun does have an impact on the tides when the sun and the moon align. The sun, the moon, and the earth align. So when these 3 bodies are aligned, we have the most extreme tides. During this time, when sun, moon, earth are aligned and we have the extreme tides, they call these spring tides. Not to do with the season. Don't confuse that with the season. They don't occur necessarily in the spring. They're just called spring tides. And then during the times when they are not aligned, they call those neap tides. Neap tides. I hope you can read my writing all right. I am an artist and a scientist, but I'm not this kind of artist. Let's get this back to satisfying order before we go. I so appreciate you joining me. I normally only have my 2 students. So it was nice to have a larger class today. Please let me know if you enjoy lessons like this, office products, office supplies, because I have a lot of them and a lot of lessons that I could teach with general elementary information. I could tell you about weather, what creates the weather. That's very interesting topic as well and relates to what we went over today. This one doesn't want to turn just right. Stay. Good. Alright, is everyone aligned? Looks nice and aligned. I put this here for us so that we could put everything up against something even. My basket's not even. Thank you again for joining me. Please let me know what you think if you'd like to see more videos like this. Thank you.